We try and build high quality homes, and a lot of them were the Adirondack style. But when you get down and look at some of the houses we built, they're really quite green. I mean, this took it to a different level.
This slab is radiant heated, and that makes it the warmest object in the building. So not only do we insulate highly underneath it, but this edge is extremely important because this edge kind of is exposed to the outside. So this would be an area that in normal construction is got a relatively low R value insulation, if any. And here we have 7 inches of rigid insulation, about R40 plus. So we've chosen to build a double stud wall here. It's 2 walls. The walls are foot thick. 2 of the walls, the inner wall and the outer wall, the frame walls, are filled with cellulose. And in between, it's a foam sandwich. So we end up with in excess of R50. It's a very high R value wall.
The roof trusses have 2 feet of insulation. There's 4 inches of insulation sprayed against the underside of the sheathing, and then 20 inches of cellulose dense packed against that, which is an unbelievable amount of insulation.
The advantages of this kind of thing, first of all, we achieve the high R value I'm looking for, but we're also always interested in what's called drying potential of the wall. If one side or the other gets wet, and that could be from physical water, rain, or a leaky roof, anything, or it could be from moisture driven from inside the house that's created in the building. By putting the impenetrable, impermeable layer in the center, the outer wall has drying potential to the outside, the inner wall has drying potential to the inside. So it creates a wall, it's very, very difficult for it to fail. It doesn't really have what's called a dew point. There's no place for moisture to condense in the wall.
The outermost layer is the shingles that you see. Behind that, there's a little bit of an air space that's created to help that breathe, and that's a durability factor, so the shingles will last a long time, be able to dry, have longevity. Behind the shingles are the zip wall. And what that zip wall system is it replaces what often historically, and even not that long ago, we'd use tar paper or Tyvek or house wrap. It's really critical that we seal up the air, and the way we're doing that on the outside of the house on the zip wall is we tape all the plywood joints, and we tape that down to the plate of the house that's on the foundation. And then we tape that up to the soffit and then the roof. So we have a very continuous barrier.
I mean, we always thought we were building a tight house, and we did. We built tight houses, but we learned a lot of things here about making it even tighter.
We've done several blower door tests, which tests the air tightness of the envelope, and that's incorporated into the energy calculations.
You pressurize the house, basically. And then that, because of the difference in atmospheric pressures between outside and inside, if you set off a smoke bomb in a house, if you see smoke coming out, you know there's some kind of leakage there. That means you're going to leak heat. You're going to lose heat. So you've got to find that problem and fix it.
So really, that outside surface of that plywood is probably the most important energy feature of the home. And that was an aspect that we had to really coordinate with all the trades, is right away, the electrician, the plumber, everybody knew anything that had to go through that eventually had to be on the outside of the house had to happen now. We couldn't happen later where all of a sudden we're going to be going through several layers and then having to patch up a whole 1 foot thick hole. We need to have the spigots going out, and we need to tape around them while we have access. We have to foam around them when we have access.
A lot of attention to detail you wouldn't normally do in a normal construction. Caulking plates and sealing different things and stuff like that. I had them even caulk all the joints where we had double 2x4s and stuff like that. So it's pretty tight.
Whether it's caulking, whether it's putting up an extra piece of wood, blocking, using sheet metal, whatever it is, all of a sudden when you hook a fan up and you see this huge draft, it just makes energy visible, and that's a huge thing, and I think that's something that people start to understand.
It comes down to a lot of careful detailing.
Like the insulating and creating a wall that breathes when it's that thick and that insulated. We learned things there. The zip guard, which is the sheathing on this building, is a very interesting thing. We would use that we definitely will use that again. It saves time, money, and it's better.
And then the key to all of this is super insulation. You need to have a tight home. And when you have a tight home, that requires a ventilation system, which is good anyway. So we have a ventilation system that's very efficient. It exchanges the air X number of times per day. So you don't need the windows open during the winter to do that. You can just still have a closed house. It's a warm house.